Okay, in the first half of the presentation, we talked about development of the blades, development of the alternator and the electronics, and in this half of the presentation, we're going to talk about the final design, the actual test data, and then putting it all together and seeing what the voltage output is. Okay, let me summarize things here. We're using 8 magnets. Each magnet position is actually two 3/4 inch rare earth magnets. The coils consist of 12 coils wound with number 36 wire. Just wind them to the capacity of the bobbin. Alright, that feeds a rectifier, and the rectifier is wired in a what's called the star configuration. The star configuration gets more voltage versus the delta. The delta gets more current. I'm using the star because I need more voltage at low RPMs. I'm feeding this into a rectifier which consists of 6 Schottky diodes, a 100 ohm series resistor, and a 500 microfarad 50 volt capacitor. And the output is fed to to a voltmeter, but more importantly, the load. The load is a small DC motor, and that's very important that you load this thing down with a substantial load. Otherwise, your voltage measurements will be they'll read high, but it will be fictitiously high, because as soon as you put a load on, the voltage would drop way down. So make sure you use a good load. The output I'm getting on this thing is roughly, I can get around 12 volts out at about 175 RPMs, and that's at around maybe 500 milliamps. So the total power of this thing is less than a watt. That surprised me that it only puts out 1 watt. But we'll work on future designs to try to get more power. Okay, let's put it all together. First, we're going to take the whole alternator assembly with the rectifier circuit attached to it and the blades, and we're going to attach that to a piece of plywood. The plywood's maybe 3 to 4 foot long, maybe around 4 to 5 inches wide. Here is the bearing, the swivel. Starting at the bottom, it's a 1.5 inch PVC pipe that it will be mounted to. Just above that, you're seeing a 1.5 inch PVC coupler that's glued to a 1.5 inch PVC cap. And the cap and the coupler are attached to each other. What I did is I took a 2-inch PVC pipe, I took a small section, I split it in half, and I applied the glue to all the sections, and then put a pipe clamp around it, a hose clamp, and that holds pretty good. Okay, just above the PVC, on the very top of the board, you might see little red things. Those are just some LEDs. I put 3 LEDs in a round circular pattern, so I can see the thing lighting up at night, to see if it's actually spinning at night. That's just a little extra thing I put in there for monitoring. And then towards the back, you see a bungee cord. We'll tie that bungee cord to the PVC pipe, and that just keeps it from spinning, multiple turns around. It can only go so many turns, and it'll keep the wire from twisting inside the pipe. And finally, I have to make a little case for this thing to protect it from the weather. Just took some plexiglass and made some panels, glued it all together, and screwed it to the alternator. Now, the one problem with the design I have here is I did not encapsulate the coils. I wanted to keep the coils, free, so I can change them out and experiment with the different wire sizes and things like that. So what I try to do is I tried to make the case go, it overhangs in the front, protect the coils a bit. In the final design, I'll probably encapsulate it just to protect all the coils. Here you see the windmill attached to the post outside, and I'm just running it very low to the ground. It's only maybe 8 foot in the air, so I can do my tests, hook up my meter, and you'll see the day I tested it here, you can see I'm only getting around 5 or 6 volts out, but the winds are only around 10 miles an hour. So hopefully with some stronger winds, we'll be able to get 12 volts, and we'll try to make some use out of this thing. Okay, that's the end of the presentation. If you visit my website, you'll find the schematic, test data, and a lot more details on the project. Okay, thank you.